In this video, we want to talk about one of the gas laws, which is Boyle's law. If we have a jar and we fill it with gases and we apply pressure on it, it's going to reduce the volume of this gas to probably to this place. If we have to increase the pressure that is being applied to this, we're going to have the volume reduced further. So the more pressure we have, the lesser volume we're going to have. And because of this, Boyle's law states that the volume of a given mass of a gas is inversely proportional to the pressure if temperature is constant. So because of this, if we want to plot the graph, a sketch, and we are plotting pressure against volume, we're going to have a hyperbolic curve. But if we are plotting pressure against 1 over volume, we're going to have a straight line graph. So from here we can have that volume is equal to, we replace this with a constant, times 1 over pressure, which is constant times 1 is K over P. Therefore, the product of pressure and volume is constant. And by extension, what it means is that P1V1 is equal to P2V2, and so on till any volume that you are dealing with. So let's solve this question. It says the ratio of the initial to the final pressure of a given mass of a gas is 1:1:1.5. Calculate the final volume of the gas if initial volume was 300 cm³ at the same temperature. These are the options. So remember the formula that we're going to use. P1V1 is equal to, so the initial, it means that P1, initial pressure, was 1 because its ratio to pressure, and the final pressure P2 is 1.5. And then they told us that we should calculate the final volume when the initial volume was 300 cm³. Now from P1V1 equal to P2V2, we're going to make V2, which is the final volume, formula, subject of the formula, we're going to have that P1V1 over P2. So if we plug in the values, we have that 1 times 1.5 times, V1, which is 300, over P2, which is 1.5, and this is 300 divided by 1.5, which gives us 200 cm³, which is option B. In the same vein, we solve this question. It says 300 cm³ of a gas has a pressure of 800 mm². If the pressure is reduced to 650 mm², find its volume. These are the options given. The same way, we have that P1V1 is equal to P2V2. So 300, so initial volume V1 is 300 cm³, and it has a pressure, so initial pressure 800 mm², and if the pressure is reduced, so the second pressure now is 650 mm². We are now asked to find its volume, which is the final volume also. So we make V2 subject of the formula, which gives us P1V1 over P2, which will have 800 times 300 divided by 650. This cancels this, so 800 times this, what we're going to get is 369.23 cm³. So the option is option B. The next question says 30 cm³ of oxygen at 10 atmospheric pressure is placed in a 20 cm³ container. Calculate the new pressure if temperature is kept constant. So in this case, you can see that the first volume V1 is 30 cm³, and from there the first pressure P1 is 10 atm. Then if it's placed, the second volume is 20 cm cube, and then we are asked to calculate P2. Feel free to pause the video and try it for yourself. So we do that by making P2 subject of the formula, which is going to give us P1 V1 over V2. If we plug in the values, we have 10 atmosphere times 30 cm cube divided by 20 cm cube. From here you see cm cube will cancel cm cube, 0 cancels 0. This is 30. 30 divided by 2 is 15 atm is remaining. So we have 15 atm, which is option B. Another question, this one says the pressure of 100 cm cube of oxygen at 35 degrees Celsius is 750 millimeter mercury. What will be the volume of the gas if the pressure is reduced to 100 millimeter mercury without changing the temperature? The same vein, we can say the first volume V1 is 100 cm cube at this, which is not really okay for us to start putting it down. This is initial pressure 750 millimeter mercury. What will be the volume? So final volume, what we're looking for. Then second pressure P2 is 100 millimeter mercury. 100 millimeter mercury. So the next thing we need to do is to make V2 subject of the formula, which is P1 V1 over P2. And when we plug in, we have 750 times V1 100 divided by P2 100. So 100 can cancel out 100. What is left is 750 cm cube. Remember to like the video, subscribe to our channel. Also, don't forget to activate the notification bell so that you can get updates whenever new videos are uploaded. Thank you.